All right, so still waiting for the Google Meet to capture the recording. Okay, now it's already started. Okay, Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. All right, so welcome for those who just joined our class. All right, so how was your weekend? Hopefully you are still in very good mood for our semester, right? Uh, have you heard any rumors on the reopening of the university? Anyone?
Yeah, I heard that our short semester is going to be face to face, but I'm not sure.
Oh, short semester. Oh, I thought they want to skip short semester altogether.
No, they're having the short semester.
Oh, okay. Because last week the uh, Minister of Education just reopened the schools. So we should expect similar things for the university as well. All right. Uh, okay. So do you remember where do we left off in the last class?
So the uh, master switch for OR gate.
Or gate, eh?
Yeah,
So
the
wait. Okay.
part
So
three, part three, sir.
I think
Yeah,
this one, right?
yeah,
Okay. Oh, we have finished this slide, right?
yeah, done. It's the
Okay.
27 slides, right? Yeah, it's done.
Okay. Or gate and okay and memory function, right?
No, no,
Okay.
no, sir. You were supposed to talk about memory function today.
Oh, today. Okay. Okay. Right. No worries. Okay. So I think we go to the next part of the hydro pneumatics today, inshallah. So I think this one is the final slide that we'll have for the pneumatics, inshallah. So uh, okay, let me see first. Okay, I think this one is the examples. Maybe we go to some examples first. Okay. All right. So let's see here. There's still people coming in. Sorry, yeah. Okay, let's see the first question. Okay, let's say we have this system. All right, so you want to toggle between the upper platform and the lower platform. You know, you want to move this parcel, and you can switch between the upper ones and or the lower ones. Okay, all right. So the question, the destination of the swiveling slide upper or lower is decided by means of a valve with selector switch. All right. So this one, before this, we only see the examples using push button. So this one is using selector switch. The upward motion of the double acting cylinder is to take place in 3 seconds. The downward motion in 2.5 seconds. Okay. Pressure on both sides of the piston is indicated. All right. In the initial position, the cylinder assumes the retracted end positions. Okay. So can you do this? Have you any idea how to solve this? Right. I think this one is the simplest one. Okay. Simplest one because you just want to toggle between two positions. All right. So let's say because we assume that the initial position is in the retracted position. So meaning that for the lower parts, it is retracted. So if it is in the advanced position, so this, this platform will go to the upper position. All right. So uh, as simple as this. Okay. So you have the selector switch here instead of push button. Okay. S- Uh, so you you have two positions you can select. Right. So in the initial position, it is retracted position, and if you select the other position, you will go to the advanced position. All right. Okay. So uh, I think we haven't seen this thing right before, have we? This one V1 and one V2.
No, no, I haven't.
No, sir.
Okay. So this one, if you go through the slides, because it is in the first slide of the pneumatics, I think. So this one is called the one-way flow valve. All right. One-way flow valve. So as the name suggests, it will allow only the flow only in one direction. All right. So for example, here in the retracted position, so you go uh, from port 1 to port 2. Right. So we don't have label here. So this one it should be port 1 to port 2, and then go through 1V2. All right. 1V2. Okay. So if you see in this diagram, where which path will it use to go through this valve? Through the ball or through this one? All right. So I think this one must be familiar for you. Have you seen this in your electronics or instrumentation or something? This one, this symbol?
Is it hysteresis, sir?
Nope.
This
This one.
magnet or something?
Have you seen this?
Oh,
Forgot, sir.
Huh? Anyone else? Do you have any idea?
No, sir.
Like this, right?
No.
So this type of things, color. Okay. All right. This type of things, I think you can find this. When you do when you have the for example, the potentiometer, right? I think potentiometer like this, right? Something like this, right? Something that can be variable, right? That you can set the value. Okay. Uh, potentiometer? Still remember? Okay.
Yes,
Potentiometer.
we
So
do.
yeah, so you can actually varies the value of this, right? So similar to this, so you can varies the value of the flow that come through it. Okay. Right. So first, sorry, yeah, there's still your friends joining the class, so I need to go. Okay. All right. So let's see here. Because the ball is in the opposite direction, so I think this one will go through here, right? Therefore, uh, you cannot vary the value, right? So it will go like just like a normal condition, right? Okay, so it will go through here, right? What is this? 1Z2. This one.
This to control the pressure, isn't it?
Okay, so this one is not to control. This one is to monitor the pressure, right? So it's like your multimeter or something. Okay, so you can see the pressure here. Okay. Okay, so this one is your pressure meter. Okay, so we'll go through here. Okay, because the path is open, the ball is open. So go through here, and then you will have the reading of your pressure here, and then go through here. Therefore, retract, right? The cylinder will retract, and the air in the other direction will go through here. All right. You also have the pressure reading here. Okay. Right. For this valve, which direction will it go? To the left or to the right? Anyone?
To the right.
So what did you ask?
To the right. Why?
Can
Why?
you put the answer? If you have any problem, you can ask me now.
Why? Why?
Everyone have submitted what you have done just now, right?
Now we have. Can someone turn off the mic? Okay. All right. Okay. So right now it will choose the right one, right? Because this one is blocked. Okay. The you have the ball here. It will block the path. Okay. So it cannot go through here. Therefore, you will choose to go to this direction. All right. Therefore, you will have the control of your flow here. So you can control the speed for the retraction. Okay. Here. Okay. So instead of going full speed, you can put maybe 30% of the speed. Okay. Okay, and then they will go through here, and then go through port number 5 and go to atmosphere. Okay. So this is for the initial position. So and then how about if we select the other position? Okay. So let's say we have this position now. When you push this, you change the selector switch. Okay. So now you have the flow of air from port 1 to 4. All right. And then you go through here. All right. Okay. Right now, because the ball is not, the path is not blocked by the ball. Right. So now we will choose here. Okay. Therefore, you cannot change the speed of your air. All right. So you will go through here. All right. And then you will have the reading again. Go through here. And then this one will make the cylinder go into the advanced position. And then the air will go through here. All right. The same thing. So because this one is blocked, it will choose the path in the right. Okay. Therefore, you can control your speed now. Right. Control the speed. And then you go through here. Okay. So you see here port 2 to port 3 and go to atmosphere. Okay. So you can imagine that for the forward and retracted position, okay, you can control in both direction. Okay. So in the advanced, you can control the speed. Also for the retract position, you can also control. Okay. So let's see if we can do that in our things. Okay. So go to fluid sim here, right? So this one is in your previous class, right? So I think this one is shuttle valve, right? Or and then here, and then if you go to the full extension, right, it will trigger this switch, right? 1S3, okay, which is a limit switch or roller lever. All right. So when this one is triggered, therefore this one will be triggered and will change the position, right? So just check this thing if this one is still working again. All right. So you can see if we push the foot pedal switch, go, and then like what happened? Cannot. Oh, this one is not. Okay. Let me check. This one, 100 should be okay. Okay, go to full extension and then directly go to the retraction. Okay, so let's put some one-way flow control. Okay, where is one-way flow control? Here, one-way flow control. So you need to stop this one first. Okay, all right, so let's rotate this. Okay, we delete this one first. Admit. When do we need to include the meter, sir? So you include the meter if you want to check the pressure. That's all, right? It's like you put your multimeter to check the voltage and current, right? Okay, so this one let's put here. Okay, let's see what happened. So suppose this one should go to this and nothing happened in the retracted position. All right, so this one suppose it will control for the advance. All right, so let's see if this one works. All right, so if we push button, so because this one we put 100%, so you can put this maybe 40%. All right, we want to allow the opening of this one-way flow meter valve to 40%. All right, so this one, all right, so you will go slow, right? Go to the full extension, will trigger the A1 S3. So this one is triggered, and then we will change the position of this valve. Okay, right? Once more. Why cannot? I think this one not triggered or something. Okay. All right. Okay, so if you want to control both, you can put in the both direction. Okay, or maybe you want to control only the retraction part. All right, just delete this, and then you can control the retraction. Okay, so for the extension, it will go in the full speed, and then when it go in the retracted position, you can control the speed to 40%. All right. Okay, like that. Okay, hopefully everyone understands this. Okay, and then you see here, right? So we have covered this for the first example, right? Let's go to the second example. All right, so operation of two identical valve by push button causes the forming tool of an edge folding device to thrust downwards. All right, so this one, let's say we have a plate like this. Okay, we have this plate. Okay, all right, and then we want to fold this one. Okay, so you want to move this cylinder from downwards. Okay, so this one will bend like this. Okay, so if both or even just one push button is released, double acting cylinder, all right, double acting, slowly returns to the initial position. All right, the cylinder pressures are indicated. Right, so there are several keywords here. So the first one is this one. All right, if both or even just one. All right, or just one. Okay, so you have two push buttons, right? So you have two push buttons, and then you should have one or valve. Okay, so push button, and then because okay, if both or even just one, okay, so meaning that this one should be or, okay, or like this. So it's released, double acting cylinder slowly returns to the initial position, right? So slowly, right? Slowly, meaning that we need to control all right, to the retraction of the double acting cylinder, right? Of course, using the one-way flow valve that we see just now. All right, and then the cylinder pressure are indicated, so you need to put the meter as well. Okay. Okay, so this one, so you put the all valve, all right, to go in to make it advance, all right. Okay, and then this one you put the spring, so you don't have to detect the full extension anymore because you don't have this for your task. Okay, so you put the cylinder, so therefore if this one is either one of these push button is released, okay, so this spring will take effect and it will return to the initial position. Okay, so you put this as well, all right, so that the return or the retraction will have you will have the control for the speed of the retraction. Okay, all right, so and then you can see new things as well here, right? Do you know what is this? Right, so for someone who have gone through the first slide, so this one is already there. Okay, what is this? Can someone tell me? Anyone? Okay,
Sharp or something. Remember.
so this one is quick exhaust. Okay, quick exhaust valve. All right, quick exhaust meaning that, you know, instead this one will go through here and then exhaust through this port, right? This port 3 into the atmosphere, right? All right. Instead of that, we will go directly to this and then directly go to the atmosphere, right? So normally this one is put near the cylinder, all right? So because, you know, in real application, sometimes this thing, you know, this DCV here and your cylinder, you know, is very far apart, right? Very far apart. So you will have this piping system here, very long, you know, from this port of cylinder to the DCV here is very long, right? So if the pipe is very long, so you there is a chance that you know through times it will accumulate high pressure, all right? So therefore you need to, you know, instead allowing it to move through your long pipe here, long piping system, just to exhaust the air, what you can do is you can include this quick exhaust valve, right? So near to your cylinder, so that you can exhaust the air easily, right, and quickly, right? Okay, so how this one is, let me erase first, right? So how this one is done. Okay, so in the initial position, okay, so go through here, all right? So because this one is open, we go like normal. Okay, go through here. Okay, and then because this one is closed, this one you can control the speed. Okay, can control the speed of the retraction, right? Right, and then go through here and go to the atmosphere. All right. Otherwise, for the if you trigger one of this push button, okay, this port, okay, this port will take effect. Okay, this one normally put it as port 1-4 because it will allow the flow from port 1 to port 4. Okay, so you have the source from 1 to 4 and then go upwards. Okay, go upwards here and then go to this way and make the cylinder advance. Okay, and then go to here and it will be exhausted to the atmosphere quickly by this valve. Okay, quick exhaust. Right, this one is very important, for the application that involves very long piping system. Okay, all right, so hopefully you get this one as well. All right, so yeah, in the last example you have this, and then for the second one you have this. So this one we just add the OR gate and the quick exhaust. All right, so you need to get all the keywords here. All right, so for example this one involve OR valve, and then this one slowly returns, so that you should control the return of the cylinder, right? And then cylinder pressure are indicated, so you need to put the meter, right? So you need to make sure that you capture all the keywords of the questions, right? Right, so and then the last one, okay, so this one is measuring rod marked in red with there is a choice of 2 push buttons to start the forward movement of the measuring rods. All right, via cylinder 1A, right, which has the exhaust air throttle. All right, the idle stroke, also started by a push button, can only take place when the double lattice has reached its forward end position. All right, so this one you need the you need to check the extension, the full extension. All right, and then you need to make sure that you end this with a push button. All right, because this push button cannot activate the system unless this one has reached the end forward position. All right, like this. Yep. So this one, so you have 4 switches. All right, and then we add this one for this example. All right, okay, so that this switch can only take effect if this one is also activated. Okay, all right, where is this one? Here. All right, so this one will check the forward end position, the full extension of the cylinder. All right, so meaning that if this one is in full extension, so this one, when this one is triggered, this one can be activated, and therefore this patient will be selected. Okay, that's the only difference from the previous one. Yep. You have
So,
any question?
so when do we know that we have to use the quick exhaust?
Oh yeah. So when do we need quick exhaust? So in real application, if you have if you position this cylinder, and this DCV are very far apart. All right, very far apart, meaning that you will have this. Sorry. So you will have this pipe here, very long, right? This both pipe is very long, all right? So when this one is very long, all right? So as the time goes, this one will accumulate a very high pressure, right? Along this one, right? And
Yes.
then as well as will take some time to exhaust, right? Just to exhaust, you will need to travel very long way, right? So instead of that one, you can put a quick exhaust near to your cylinder here, right? So this one is quick exhaust. Normally this one is very near, so just side by side to the cylinder. Okay, so you can quickly exhaust the air to the atmosphere. All right, that's how you can know that you need the quick exhaust. Okay.
Sir, in the question, like which keyword would say that like we need quick exhaust?
Yeah. If you look in the last question, so this one.
Yeah.
Okay. That's a good question as well. So like this one, we have the quick exhaust, right?
Yeah.
So and then this quick exhaust is also important for the application that need the very high speed. All right, very high speed. So for example, this one, you need to bend this metal sheet or something, right? You need to give a very high speed to this. Therefore, you need the quick exhaust. All right. So this one, or maybe you want to make the stamping application. All right. That you need very quick, the very quick direction of the cylinder, very quick movement of the cylinder. All right. So you can choose the quick exhaust as well. All right. So that's another keyword as well. Okay. Look at the application. All right. So this one you understand, huh? So we add this N valve. Okay. All right. So can we move to the next one here? All right. So more examples. Okay. So let's see here. What do we have? All right. So piston rod of the cylinder 1A is to advance only if a workpiece is inserted in the workpiece retainer. All right. So you have a workpiece here. All right. So you need to check that the workpiece is there before you can start the system. Okay. All right. Only if a workpiece is inserted in the workpiece retainer, a guard has been lowered. All right. And the operator presses the push button valve. Okay. So you have three conditions. Okay. So you have the workpiece. You need to check the workpiece. You need to check the guard has been lowered. All right. And the operator has pushed the push button. Right. Upon the release of the push button, or if the guard is no longer in its lower position, the cylinder 1A is to retract to the initial position. All right. Can you tell me how to solve this?
So maybe use two AND gates.
Yep, two AND gates. And then how about the DCV? How to control the DCV? So this AND gate will be connected to DCV or how?
So first, like suppose the workpiece sensor or the switch, and
Okay.
then the guard switch should be in one AND gate. Then from the
Okay.
output of that AND gate should go to the another AND gate with the push button.
Yep. And then go to?
And then Okay. Cylinder 1, a piston rod. Then it should control. It should go directly to the cylinder switch, maybe.
So the switch, huh?
Yeah.
So this one should go to the directional control valve, right?
Yeah.
And then the directional control valve will go to the cylinder,
Yes.
right, to control. Yep. Okay.
Yes.
For any applications that you get, you should start with this. All right. So how many input is required, right? So for example, for this one, I think you need 3, right? You need 3 sensor for the workpiece, sensor for the guard, and push button. All right. How many input required? How many dual pressure valve required? Okay, to control the cylinder. All right. What type of directional valve is required? All right. Uh, is it the one with the spring or not? All right. Do we need to control both ends of the directional valve? All right. So you need to answer this question to design your complete system. Okay. And then how they are connected. All right. Suppose we have the air supply, and then we have the cylinder here. Always start with this. Okay. And then you put how many input that you have, right? So for example, you have 3 here, 3 switches, right? 1 push button and 2 for the sensor. All right. And then as Intias told just now, we have 2 AND gates, right? So what's the other name of AND gate, Intias?
Dual pressure valve.
All right. So dual pressure valve. So you need 2 of those. Okay. And then of course the DCV. All right. That will be controlled by the spring return. Okay. And then just connect all of this together to see how it works. Okay. Like this. Right. So this one you can go through by yourself. I think this one just the simple one. Just we need 2 and gates here. Okay. Right now the memory function. So in last class we have actually seen this memory function. So but most of our examples we just use the DCV with the spring return. Okay, like this, right? DCV with spring return at the other end. All right. So now memory function. All right. Okay. So before this, the actuator will directly retract once there is no longer signal at port 1-4. All right. So this spring effect will take place when there is no longer signal at the other end. Okay. So this one, right? So when you release the push button, all right. So port 14 is no longer receive any signal. So this spring will take this to the initial position. Okay. What if we want to retain the cylinder position until other signal is applied, right? So for example, this one is connected to a push button. Okay. This one is connected to a push button. Push button. All right. So and then we release the push button, and then we want the cylinder to go to the advanced position. All right. Still to retain the position unless we have another signal here. Okay. That's where the memory function is very useful. All right. Otherwise, if in this diagram, if we release the push button, the spring will return this valve into its initial position. So we don't want that kind of application. We want this cylinder to retain the advanced position unless we have the other signal from the other direction. Okay. Right, so here's the memory function. So instead of you just have one port here, you have port at both sides. All right. So if you purchase, sorry, yeah. So if you purchase this valve, right, the memory function valve, all right, you can see the label here, right? So instead of spring here, you can see that this one is also, this one can also receive signal, okay, like this. So this one is 1.4, this one is 1.2, all right. The piston rod of a double 18 is to advance. Okay, so this one you can see by yourself, right? Okay, what does this mean? So this one, if you push this push button, port 1.4 will be activated. This position will be take place. Okay, so this one will go into the advanced position. All right, and it will retain that position unless we give the signal here, right? Unless we push this 1S2 push button, and then you will receive the signal in the port 1.2, and then this position will take place. Okay, right? Can we simulate that in our here? Like this. Okay, so we have the 1.4 and 1.2 here. All right, this is the memory function. So let's make it simpler, right? So maybe just connect this here. Okay, so you can see how this one goes. So this one go, and then go to full extension, detect this one, and this one will take place. Okay, that will make the cylinder to retracted position. Okay. Okay, my question, what if we don't release this? So in this case, we just push this once, right? So this one need to be clear every time. All right, so what if we always push this without releasing? What will happen to this?
So
Can anyone?
maybe the second input will get priority, something like that. I also had this question
Okay,
from your
all
previous
right, okay. So Intias mentioned that maybe this one will also take place as well, right? Even though this port 1.4 is still activated. Okay, so we'll see this one now. Okay, what if we retain this push button? Okay, can you see now? You can see that now it 1S3 is triggered because the cylinder is in full extension, right? And port 1.2, port 12 is already got the signal, but port 1.4 is still holding the signal, right? Okay, and you can see that because of this, port 1.2 cannot take effect. All right, you can see that the position is still in the advanced position. All right, it's still selecting the left position of the DCV, right? So if you want for the other signal 1.2 take place, you need to release this, right? You need to release the 1.4, right? So if you want port 12 to take place, you need to clear the signal at the 1.4 first, right? Otherwise, it will retain the signal that it used in the last state. Okay, that's the essence of the memory function. All right, so the same like this. So if this one, for any reason, this one is always triggered, so this one cannot take place again. right? So it will memorize the state of the previous one. Okay. Okay. So this one, I'm not sure why this one is not clear. Okay. This.
Sir, I have a question about this.
Okay.
So is there any way to like overwrite the previous state? Like I want like even if the push button is pressed, I want to
Okay.
like give priority to 1S3. Like is there any way to do that?
Oh, you okay. If you want to do that, I think you can make some not gate here, or you know, or maybe end gate with this 1S3 something, right?
Okay.
And
Okay.
then the other one you make not, right? So maybe this one is in the normally uh, normally close, so instead of this, it is in the other position. So for example, this one you can add one. Okay, so instead of this, you can change to how to make it already actuated, right? Okay, so you can make this one is already actuated and put some n valve here, right? Okay, so you will check if this one is triggered, this one will no longer activated. Okay, when this one is no longer activated, 1.4 is also deactivated, and then you can allow this 12 to receive signal.
Okay, sir.
Okay, something like that.
Okay.
All right. Okay, and any more question? Okay, I think this one is not very difficult, but you need to make sure you understand carefully the function. Okay. Right, so that's the memory function. So this one you can go through by yourself. Okay. Let's do an exercise here. A double acting cylinder is to be used to transfer parts from a magazine. The cylinder is to advance fully when a push button is operated and then retract automatically. So this one is the same like before. When it is in full extension, it will retract directly retract after that. Okay. Full extension is confirmed by a roller lever valve. The cylinder is to continue forward even if the push button is released before full extension is reached. The speed of the cylinder is to be adjustable in both directions of motion. So this one is the same like before. All right. So you list the input output. Okay, and then the control function. Okay, because you use the memory function here. Right, this one just is similar ones to what we see before. All right, in the fluid sim, right, the same. Okay, so we have the additional question here, right? So this one is the same that we simulate just now in the fluid sim. All right, but we have some other questions here. So the first one, what is the effect on the piston rod movement if the push button remains actuated once the piston rod has reached the end position? All right, so this one I have already answered just now. All right, so the answer is that it will retain to the advanced position unless you release the push button, right? Unless you release the push button. All right. And the second one, what is the effect on the advanced stroke if the roller lever valve is fitted at the stroke mid position of the piston rod? Right. So instead of in the end position like this, 1S2 is positioned at this position, somewhere here in the middle. right? What is the effect on the advanced stroke? Okay. What is the effect on the advanced stroke? Will it retain the full advancement, or how? Do you have any answer to that?
I think
I
it
think
just only go to mid position.
okay, and then will it retain that position or will go to retracted position?
Then retracted.
Okay, so all right, so it will I think it will retract given that you have released this push button, right? Because push button normally you won't you won't push it, you won't maintain that push button, right? So you just push it once and release. So this one, if it goes to the mid position, when this one is triggered 1S2, so this one will take place, right? So it will directly retract. Okay, so let's try to, I think you can simulate this one also in this fluid scene. So this one, right? So this one I have put the maximum stroke is 100. All right. Okay, 100. So this one is millimeter. Okay, 100 millimeter. So this one I put I put the switch 1S3 at the 100. So this one is a full extension. So what if we put in the middle? So maybe 60 something. Okay, 60 like that. Okay, let's see how it works now. Okay, so we'll push and release. Okay, still the same, but it will go to the mid and will not go fully advanced. All right, once again, oh, this one I'm not sure what happened. Okay, that's the answer. This one can, okay. Describe the initial status of the system and then describe the operation of the circuit. Okay. There's someone drilling something in my neighborhood. So please pardon that one if you hear some noise. Can you hear that drilling things?
Yes, doctor. I hear.
But
So
very low. I think you have noise cancellation.
okay, all right, that's good. Very noisy, yeah.
Yeah.
Okay, all right. Okay, so hopefully you understand this one as well. Do you have any more question to this? I think this one is quite easy. Unless you understand this one is very easy. Okay. Okay. And then the next one is on quick exhaust valve. Okay. The combined actuation of a manually actuated valve and a roller lever valve advances a forming tool on an edge folding device. Okay. So combined actuation, meaning that you need an end valve, right? So end valve, the forming tool is driven by a double acting cylinder. All right. So 1A here is double acting cylinder. For rapid forward travel, the circuit utilizes a quick exhaust valve, right? That's what I told you before. So other than this one can help in the application that needs long piping. This one can also very useful for application that need rapid forward travel. Okay, such as this one. Okay, you want to fold this device. This sheet metal. All right. The retracting speed is to be adjustable. Okay, if either of the two valves are released. Okay, if either of the two valves are released, the tool returns to its initial position. Okay, all right. So there's lots of keywords here that you need to take into account, right? So this one you need an N valve, right? And then for 1A, you need to use the double acting cylinder. And then for the rapid forward travel, you need the exhaust valve. And then you need to adjust the retracting speed. Okay. Okay. As always, you need to start with this input and output. Input is the source. As I told you, if you are lazy to do this, you can put just the triangle one. Okay. It's okay for me. All right. And then double acting, push button valve. Okay, roller lever to detect workpiece. Okay, end position, end operation, sorry. Okay, and valve. And then you have the DCV, rapid forward travel, which is the exhaust valve. Okay, and speed control. Okay, so you will have something like this. All right. So you can go through this one by yourself, but basically I have already covered this in previous ones. Okay, so you need to be careful. This one can be in spring return. It can be in memory function. Okay, so you need to be careful. And before this, normally students also, they forgot to put the spring here for the switches, right? Which is very important, because if you don't have spring, this one cannot go back to the initial position, right? So don't forget to include the spring as well, right? And then you need to make sure you really understand this port designation, right? What is port 1, port 2, port 3, port 4, right? Where is the exhaust ports as well? Okay. Okay, and you can see for the exhaust valve, you also have the port designation as well, right? Port 2 and port 3. Okay. Right. So before that, do you have any question? Before we go through to this pressure dependent control?
Doctor.
Yep.
Uh, you say that if the pipe is too long, then we need quick exhaust, right?
Yep.
Then how do we know that the pipe is long or the pipe is short? I mean, what is the threshold for long?
Yeah. So this
short?
this one can be determined by checking the pressure condition. All right. So depend on your application. So this one of course depends on your type of piping system and the DCV as well. So if your pipe allow for certain pressure, because if you purchase the piping system, you will have the rating for each pipe, right? So for example, this pipe can stand for how many pressures, right? So depend on this. So you check the pressure going through the pipe. So if it is very very high, so you need this quick exhaust. Otherwise, if your pipe can withstand very high pressure, then you may you may maintain your design as is without the quick exhaust. All right, because if you want to use the quick exhaust, of course you need to buy a new one, right? So this one, so if you ask how to determine this, so this one based on the rating of your pipe, and then you need to check the pressure condition of your system, right? If it allow those kind of pressure rating. Okay. Sir, can you explain again the pressure flow in the memory? The memory, what do you mean? This one for the memory function? Muhammad Azhar? Yes. Okay. So, right. Where is it? Memory. This one. So we have two types of DCV. So this the first one is with the spring, and the second one with this one, right? So here, all right. So DCV can be in this one using the spring return, or it can be it can allow signal in both direction. Okay, so if this one is used, meaning that if there is no longer signal in port 14, all right, this spring will take effect. All right, meaning that if you for example, if you push your push button in the left hand side, so you will have the signal at port 14, right? Port 14 meaning that this position will be used. Okay, this position will be used, which will extend the cylinder. All right, and then when you release the push button, okay, and port 14 is no longer be activated, all right, this spring will pull this DCV to its initial position. All right, so it will directly go to the retracted position. All right, otherwise for the DCV with memory function, you have this one without the spring. Okay, so when this one is when port 14 is no longer receive any signal, so you can trigger this port 12 to change the direction of the valve. All right, and vice versa. If port 12 is no longer receive signal, you can give signal to the port 14, right? So you can change the position of your DCV using two inputs. Okay, instead of for this one, you can only control in one position. Okay, this one you can control for both, right? When you want to extend, when you want to retract. Okay, that's for the memory function. Okay, why it is called memory function? Because it will memorize the state of the previous one. All right, before executing the new signal.
So
Okay.
I still don't understand.
Oh, still don't understand.
Yeah.
Okay. Can you see the difference between both?
Yes, sir. One have spring, one doesn't have spring.
Okay. I think better we go to the simulation to see more clearly. Like this. Okay. So, okay. Let's put this spring return at the right actuation. Okay. Oops. So this one will clear this one. Okay. So you can have this one is the first type of DCV, right? So instead of this, you can have, or maybe we just copy the whole one. We copy the whole one. Before this, delete first. Okay, copy. Okay. So this one, you put this. Okay, and you can put another. Maybe we delete this. Okay, so so you have these two kind of system, right? So at the left hand side, you see that our DCV is spring return. Okay, and for the second one, we have DCV. How to move this one? Let's make it smaller. Okay, and for the right hand side, you have the DCV that you can control at both position. Right, you can control the advance and you can control the retract. Okay, if you see the function object outside pula dah. Okay, so we need to okay like this. You need to add the force here. Okay, all right, so if you see at the left hand side, if you push and release, you push release. Okay, this one will be returned by your spring. Okay, you push release, this one will be returned by your spring. Otherwise, for this, if you push this, you will remain at this forward position. All right, unless you give the signal to the other direction. Okay, unless you give signal to this port 12. Right, how to give signal to port 12? Can you tell me?
Just push the push button.
This one, right? Okay, so if you push this, you will go to the retracted position. Right? That's the difference. So this one will return by means of this spring directly. All right, but this one will be returned by the invocation of port 12. All right.
Sir, I understand. Azhar also asked, what if we press both push button at once?
Okay, if you press the both push button at once, it will choose the first one because it should memorize the previous one. All right. So let's say we have this. All right, and we trigger this, but this one is still there, right? So maybe you want to see that one, maybe you change this to selector switch or something. Is this selector switch? Yeah, selector switch. I think this one is selector switch, right?
Sir, you can
Yep.
use the next switch as like sensor for full extension. So maybe you can select both at the same time then.
Let's try this one first, okay?
Okay.
Okay, this one is this one.
Okay.
So this one is selector switch. So this one is always triggered, right? So this one is already in full extension. All right, what if we push this? Okay, you can see port 14 and port 12 both are activated. Okay, see, but it will memorize the first one. All right, it will memorize the one that trigger first. Right, unless you clear this one, unless you clear the port 14. Okay, you clear this one, so port 14 is no longer receive any signal. So, and then you trigger this, then you can retract this cylinder. Okay. Do you understand that one? Which the one who asked? Mama Azhar? Okay. All right. So hopefully you can get some sense of that. Okay. Yep.
I have one question. I cannot visualize the quick exhaust system. Can you add the quick exhaust here?
Yeah, sure. So quick exhaust, you can add here. Quick exhaust Q. Where's Q? Can you find me the quick exhaust? I'm not good at searching this.
I think that's the very last. I'm not sure.
RSTQ. Address a quick exhaust just now.
Sir, next to push button.
Next to push button. Oh,
Go
very
to
good.
push button.
Very good eye, huh? Very
Oh,
good eye.
very good.
Okay. So one always the source, okay. Two to the working parts, okay, and three to the atmosphere, right? Lines through connection. Wait, what I did here. Okay. All right. Let's try this one. Okay. So what happened?
It's a selected switch. That's why.
Select the switch. Sorry. So this one will take place when this one is in advance, right? So this one will go like very fast in the advanced position. Okay.
Yeah, I can visualize it now. Yeah. Okay, sir.
Okay.
Yeah. The opposite one is basically to make slower, and this one is to make it quicker, right?
Yep. This one way flow valve is you can control the speed. This
Okay.
one you can go in the full speed.
Yeah.
Okay.
Yeah.
And any more question?
Sir, I have question.
Okay.
When should we place the control? I mean the speed control valve.
This one.
That one.
When?
I mean,
So
which application is suitable?
this one is if you need if you want to to limit the speed. So for example, if you want to as the selector, for example, right? So maybe you don't want the cylinder to go to a very high speed. All right. What are the other application of this? So maybe maybe for the door, for example. All right. For the door, maybe you don't want to go in full speed, and you want to control the extension and retraction. So you can put this flow control valve.
Thank you, sir. I understand.
Okay. All right. Okay. Any more question? I think some of you will have class at 10. So we take one more question if there's from anyone. Sisters, are you okay? Where are sisters? Sisters in this class is very shy, huh? So let's see. Nur Shazwani, are you there? Do you have any question? Are you understand this class?
Not now, sir. Not yet. Maybe later if I try some exercise.
Okay, okay. So Kira, are you with me? Still in Langkawi? Looks like she's not there. Okay. Shamimi, are you there? Shamimi, with that end.
Okay.
Okay. How's your PKP? Are you okay?
Inshallah.
Doing fine. Okay. All right. So I think we only have after this we only have the pressure dependent control and the time dependent control, and then we'll finish the pneumatics. I'm thinking of going for our next quiz. Okay, your second quiz. Can we have the quiz this Wednesday? Anyone?
No.
Wait. No. Why?
I think we need to understand a bit and we do some practice.
Okay, then on Thursday.
So maybe you can just upload the quiz and we will attempt, like, to give us.
Yeah, like before, maybe 4 or 5 hours.
Oh,
Right? Yeah, 4 or 5 hours, or maybe this one is easier, maybe 2 or 3 hours.
so maybe the weekend, sir.
We cannot because
We got midterm. Some of us got midterm.
Oh yeah. Midterms.
oh,
Yeah.
some of you got midterm on the weekend.
Yes, sir. I have 2 midterm.
Okay, so yeah, I think the best option is on Wednesday.
Thursday is also considerable.
You know, maybe at like before start at 5 something.
Yep. Not sure. But I'm fine with
Same.
both. I'm fine with both Wednesday and Thursday. Thursday is also fine. Or do you have any concerns for Thursday?
Thursday. Are you all okay with quiz on Thursday? This Thursday.
I don't think I'm okay
Why?
because I'm requesting to make the quiz, to propose the quiz on next week, if you're okay.
Because next week is already, you want to prepare for the midterm. Midterm is on 17th, right?
Sir.
Yeah, 17th. So I think maybe if you do the quiz on Wednesday or Thursday, so next week we can discuss on the quizzes that we have done. All right. And you can ask for the midterm as well. How's that sound?
I think if that is the purpose, then I agree.
Okay. So okay, can we all agree on Wednesday evening, 5 maybe to 9 something, 5 to 9.
So I have class on 5.
Wait,
Skill
class is that,
class.
bro?
Skill class.
Skill
Class,
Yeah.
Yes.
class on
Skill.
Wednesday.
Yes.
How about Thursday?
Oh, come on.
Thursday, Faris. How about
I
Thursday?
can show my timetable.
Okay. So
Thursday, okay.
how about then we go for Thursday at 5. Okay.
Have class
Okay.
also.
Too many classes, huh? What class now? Thursday, what class?
Mandarin class.
Sorry.
Mandarin class.
Oh, Mandarin, huh? All right, Mandarin. Why don't you take Korean or something? Okay, Mandarin, huh? No, after this, you can teach me the Mandarin as well. Okay, so how? For those who have Mandarin class, do you have any proposal? Maybe after Mandarin class.
Okay, sir.
When-
After 7.
After 7. Alright, so maybe we take Wednesday after 7. Okay. Wednesday
sir.
7 to 10.
Sir.
Yep.
Let's just keep it open from 5 to 10, maybe, because like after 7 we have to study for something else. So
Yeah. I think I just open it from 5 to 10, right?
Yeah.
Okay. I think Wednesday 5 to 10. Let's agree on that.
Okay, fine with it. Agree.
Okay. All right. So if no more objection, we can stick to that proposal. Huh? Okay. Inshallah. I think we finish our class first and see you again on Wednesday, inshallah. All right.
So what topic? What topic quiz tu? What will be covered?
Pneumatics. Fully pneumatics. All.
Okay, sir.
Okay. Of course, it is open book, open internet, open discussion between you. Okay.
That doesn't help, sir, in your quizzes.
Okay. All right. So okay, let's finish this class. All right. Thank you. See you again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.